Here we want to solve a differential equation. It's second order. It's homogeneous because it's equal to 0. And we've been given some initial conditions. So if we go back to our template, our first step is to let y equals e to the kx. We then find the first and second derivative, and then we substitute them back in to find k. So first of all, let's do y dash. Derivative up there is k, so it'll be k e to the kx. And y double dash, once again, derivative up there is k, so it'll be k squared e to the kx. Okay, so we haven't got x's here, we've got t's, haven't we? So we've got to fix that up. Alright, so this is a function in t, not a function of x. Okay, so we've got y dash, y double dash. Now we substitute back in the original equation, so instead of d2y dt2, we can substitute that with k squared e to the kt plus 2 y dy dt is ke to the kt, so that'll be 2 ke to the kt plus 3y, y is e to the kt, so that'll be just 3 e to the kt, and it's homogeneous, so it's equal to 0. Okay, now we can divide by e to the kt, unequal to 0, and we get k squared plus 2k plus 3 equals 0. And we use a quadratic formula to actually work out values of k now. So third step, so we've got a is equal to 1 for our quadratic, a is coefficient of k squared, b is equal to 2, c is equal to 3, and you get k equals minus b, which is minus 2, plus or minus square root b squared, which is 4, minus 4ac, 4 times 3 is 12, all over 2a, which is 2. Okay, minus 2 plus or minus square root of 4 minus 12, negative 8, all over 2. Negative 2 plus or minus square root of 8, negative 8, sorry, is square root of 8 times square root of negative 1, all over 2, equals negative 2 plus or minus. Now that's going to be an I. Now square root of 8 can be reduced to root 8, root 4, root 8 can be reduced to root 4, root 2. 2 4s are 8, and that'll be I all over 2 is equal to negative 2 square root of 4, so plus or minus 2 root 2I all over 2. Now we can't cancel this 2 with any of those 2's because they are connected by pluses and minuses. So we have to factorise and take the factor of 2 out the front. Negative 1 plus or minus root 2I all over 2. So what I've done is taken 2 as a common factor to both this term and that term out the front. Now we can cancel those 2, and we can say that's equal to minus 1 plus or minus root 2I. Now that means that we've got, if we go back to our template, we've certainly haven't got real roots. We haven't got the b squared minus 4ac being equal to 0. So we've got complex roots. So we've got k1 equals p plus iq. So that'll be equal to negative 1 plus root 2I. And k2 is equal to negative 1 minus root 2I. So that gives us a value of p is equal to negative 1, and q has a value of root 2. So now we can state our general solution. Going back to the template, y equals, now e to the minus, it goes e to the px, or pt in this case, outside of a cos qt plus b sine of qt. That's the general form. We've got values for p and q we can substitute in there. So we've got e to the minus t, a cos, now q is root 2, so it'll be root 2t plus b sine root 2t. Okay, now that would be the general solution of this differential equation up here, but we've been given some initial conditions, so it will allow us to work out some of these values a and b. So we need to find out the derivative. We can substitute in this answer we've got here, but we also need to find the first derivative of y as well. So we've got y dash is equal to, we've got a function in t multiplied by another function of t. So we're going to have to use the product rule here. So it'll be the derivative of this, which will be minus e to the minus t, because the derivative of negative t will be negative 1, times this bracket, so I've done the derivative of that times this, and then I'm going to do that times, or plus that times the derivative of that square bracket. So it'll be plus e to the minus t. Now the derivative of a cos root 2t. This is a chain rule situation going on here, so we've got to find the derivative of that. So it'll be a root 2. So a times the derivative of that. Derivative of cos is negative sine root 2t. Find the derivative of this. Chain rule again, sine of root 2t is just root 2 when we find the derivative of that, and that'll come out the front, so that'll be plus b root 2, derivative of sine is cos root 2t. So the first derivative is all of that. So now we can use these initial conditions. We know that y of 0 equals 2. So when we put t equals 0, this whole function here is going to be equal to 2. So if I go t equals 0, e to the power of 0, all this will be 0, e to the power of 0 is 1. So we'll just get a cos q is equal to root 2. So it'll be root 2 times 0. So it'll be a cos 0. So we're substituting in here. Not that one up there. So a cos, and we know that t is equal to 0, so root 2 times 0 is cos of 0, plus b sine, and root 2 times 0 is equal to 0, so sine of 0. So that's equal to 2. Cos of 0 is 1, sine of 0 is 0, so all of that is 0. So you've got a is equal to 2. So that will give us A is equal to 2. Now we know also that y dash from our initial conditions way up here, y dash of 0 is equal to negative 3. Is equal to, here's y dash, 0. So you've got e to the power of 0, which is equal to 1. So that'll be equal to negative 1. So I've got negative outside of a cos of 0. So that'll be a cos 0 plus b sine 0. So that's the first bracket, plus e to the power of 0 is 1, so there'll be plus 1 outside, don't put 1 outside of. This will be minus, now we might put the root 2 a, that'll be sine of 0, plus b, or root 2b, and cos of 0. Cos of 0 is 1, so that'll be minus a. Sine of 0 is 0, so that all will be 0. Plus, now sine of 0 is 0, so that'll all go. And here we've got plus root 2 b, because cos of 0 is 1. Now that's equal to negative 3. So negative 3 is minus a plus root 2b. We've already got a is equal to 2, so you've got negative 3 equals negative 2 plus root 2b. Bring the minus to the other side, and so you'll get negative 1 equals root 2b. So b equals negative 1 on root 2. Okay, so now we can substitute for a and b back in this equation here. So we get y equals e to the minus t outside of a, we said was equal to 2. So it'll be 2 cos root 2t plus, now b is negative 1 on root 2. It'll be minus 1 on root 2 sine root 2t. Going back through it, it's a homogeneous equation, it's second order constant coefficient, so we use the set template. Y equals e to the kt, find the first, second derivatives, substitute in, use quadratic formula. That gives us values for p and q. This is our general form when we've got complex values for k1 and k2, so we substitute in for p and q into that, and this one here is our general solution. Then we've got initial conditions which we can use to calculate a and b, so we go back and substitute those values in and come up with our final solution.